Hey everyone, thanks for coming, and thanks Eric for announcing me so nicely, and also for making these events happen. I'm Ben. Today we're going to be talking about adopting Cloud EDAs through what I call the Serverless Staircase, which is a bit of a framework of lessons I've learned by making many mistakes in the past. My name's Ben. I'm the founder of aleio. I'm also an AWS serverless hero, so I speak a lot at conferences, speak at reInvent, and work with the AWS teams on EDAs and serverless. Today, though, we're going to look at a few different things. We're going to look at what an event-driven serverless-first utopia can look like. We're going to look at a cautionary tale about what can go wrong. And then we're going to look at the serverless staircase as a set of lessons to avoid those mistakes, and then jump into some conclusions. I would flag before we kick off that we're all at different points of this journey. A lot of organizations have seen the benefits of cloud and want to adopt event-driven architectures and serverless to take full advantage. But their existing legacy technology and organizational constraints can get in the way of adopting. So event-driven serverless-first utopia, what does it look like? Well, for me, the key advantages are lower cost. That's lower cost to run, but more lower total cost of ownership, not only to build, but also to run and maintain. Higher scale, the ability to have higher stability at scale and be able to scale dynamically to our demand. Faster development, my favorite one, being able to build things faster and ship faster, and all of this coming together to enable higher experimentation. There's an IDC study that's actually getting a little bit old that shows some of the benefits of serverless alone. And I realize I'm talking about serverless, and some of us have been talking about serverless today and event-driven architectures, and why those two things go together is that actually serverless by its very nature is very event-driven. Lambdas respond to events. DynamoDB has streams. EventBridge brings things together. By building good serverless, we're often building good event-driven architectures. Now, on the benefits of this sort of serverless-first utopia, what we're trying to get towards, there's a book by David Anderson, who you all know from this morning, that really helps sort of frame why to move towards event-driven architecture, why to move towards serverless, and how to align your organization on that journey. So very much suggested reading. But that's sort of where we want to get to. They're the benefits, they're the return on investments of moving to serverless and event-driven architectures. But it's not always that easy. So sharing a bit of a cautionary tale of how this can sometimes go wrong. I was once helping a large e-commerce to migrate to serverless. They were transacting billions of euros a year. They had a large legacy monolith built by a series of outsourced partners. Everything was on-premise. They had a large team doing supports, and only whole system deployments were possible. You couldn't ship different parts of the system independently. You had to ship the whole thing together. Pages were taking multiple seconds to load. It was becoming a real problem, and they were having large-scale downtime events. Now, luckily, they wanted to move to serverless and EDA to solve all these problems, but they wanted to do it in one step. They wanted to go from on-prem monolith all the way to serverless, cloud-native, event-driven architectures, and they wanted to do it as a big bang. They wanted to keep their existing system development going, keep that at the same level of productivity, just rebuild the last 5 years of what they built, and then somehow get ahead and at some point flip the switch and do a big bang release into production. Some of you might realize this isn't going to go particularly well. The new organization they set up had 80 engineers from day one. They hadn't decided the tech stack yet, which was a fun meeting. And they were going to just build as quickly as possible, take over the existing system, and then go into production, which led to 2 organizational units working completely in competition with each other, and a lot of not so great results. The new team they brought in were not experts in the business or the institution they were building within. The existing team pretty fairly actively sabotaged their progress, and the system kept growing. It was a race between 2 different teams. No assumptions were tested, because in a big bang release strategy, you just try and build everything and then one day switch it on. A lot of things aren't going to work in practice. And one of the most important things is the move to serverless, the move to event-driven architectures. That was all to realize a culture of continuous delivery. But that culture wasn't built during the modernization itself, which meant that actually teams didn't move or change their mindsets. Zero value was really shown to shareholders, and the team was very demotivated because there was little chance of success. Many teams were very stuck to make progress, and some of the poor existing design decisions of the existing system were repeated in the new system. So the result of this was really 2 successive modernization programs that started and failed. Several senior leadership team members had to resign. No value was shipped to users, and there was a significantly degraded relationship between the technology and the product departments. And outside of all of this, we threw away just a lot of code, which is never an enjoyable thing to see happen. So that's a multi-million-pound investment in technology down the drain. And this is what I like to call the field of dreams trap. If you build it, they will come. You can't just build a new system and completely shift paradigm, and especially get that done externally, hand it over to a team, and then say, this is now your system. People need to be brought along on that journey, and it doesn't matter how nice your landing zones are, your platform teams, your documentation, you have to bring people along on the journey. So what did I do? Of course, this is now my caveat to say none of this was my fault. I was there facilitating domain-driven design workshops in parallel to this program, was brought in midway through. But I saw all this chaos, I saw this waste, all the politics, all the risk, and I kind of had the decision, do I say something or do I quickly get out of this chaos? Decided to say something, had quite a good relationship with the CTO of this organization, and sort of made a case for change. He agreed, but he agreed only if I was going to present it to his rather scary board of shareholders. So then that cut me into a somewhat intimidating meeting where I basically told them, the last £5 million you spent has been pretty much wasted, you need to start again, which they weren't particularly thrilled about. Summarizing the conversation slightly, they asked what happens if we don't change, and I basically said we have the same conversation in 6 months, but it's going to be a lot more money down the drain. And they said, yeah, okay, we buy into it, we need to make a change, but what's going to be different this time? And this is what led me to build the Serverless Staircase, to try and take my experience across modernizations with different customers across different industries when they're trying to adopt serverless and event-driven architectures, try and find the anti-patterns and try and find some common tools to fix those problems. So we're going to go up the staircase from 1 to 5, look at each of the different areas that you need to focus on, and then look at some tooling, both organizational and technical, to solve those issues. Now, the first part isn't that surprising. It's vision. David Anderson talks a lot about this, having a good North Star vision, having leading indicators, and having a clear target states. The key here is to make sure the board actually buy into this, and there's buy-in across the organization. And obviously, KPIs have to be measured during the program, not at the end of the program, and you have to have good governance to enable that. Two of the key tools here are having a good business case and having a good, what I call, vision workshop. But business case, it sounds really obvious. If you're going to make a huge change paradigm, change technology stack, move to serverless, people assume that things are going to get better, but they rarely actually write down the narrative as to why. That's key for your team to understand and be motivated, but it's also key for the other parts of your organization to understand the work you're doing. It's not purely going to impact the technology team. The other part is the vision workshop, so actually getting people to align on what the North Star metric is. David Anderson's book, again, I'm going to say David Anderson quite a few times in this talk, really brings this up as well as one of the most important parts, but figuring out what is the North Star when we come to migrating to a modern serverless event-driven architecture. For some people, that's going to be reducing the time to value, the time it takes from an idea in a boardroom through to user feedback in production. For others, it's going to be reducing the MTTR to meet SLA requirements. And for others, it might be reducing the total cost of ownership of their system. The key is to pick one and understand why you're actually doing this move. And then in an Amazon style, you can work backwards to figure out your input metrics and then the medium to long-term business results, which gives you a framework to actually report success inside the organization. Next, getting more technical, is the topology. So the important part is to map out the topology that you want to have. And that can be architectural topology, but it's also going to be the team topology. If you've read the book Team Topologies, you'll be familiar with the reverse Conway maneuver, but really knowing that an organizational structure is going to be repeated in your code, change your organizational structure to get the resulting code structure and architectural structure that you want. The key here is to make sure that we have the right split up of teams and leverage domain-driven design to do that, to make sure we have the right event schema. Event schema and event-driven architecture, that's your key contract between teams. If you don't get that right, a lot of this doesn't work. And also, we need to make sure we protect the cognitive load of teams so they can be efficient. So we don't have to understand the whole system in a team. We need to understand our particular bounded context. Event storming, I'll dig into in a moment, is a really good tool. It's an extension of domain-driven design, and that helps us to understand the events that we have and helps us to map that target architectural topology. As I mentioned, event storming is an extension of domain-driven design. It's a really lightweight way of discovering a domain. Basically, you get a load of stakeholders in, business and technology, that's the important parts. You discover the events, the entities, the aggregates, and the bounded contexts, and really you start to then dig into the events and figure out their event schema. I have an extension to this workshop called Event Bridge Storming, where we go a little bit further. So first of all, yes, we do event discovery, we do temporal sequencing, putting things in order from left to right. We figure out what the triggers are, we categorize those into aggregates, and then you build your bounded context, your areas of your system that can be independent. And then naming microservices, obviously one of the hardest things to do, but figuring out what independent microservices you're going to have, and then creating what the event bus will be, could be Event Bridge. And then the most important part is having a good event schema and storing that in a way that's discoverable to other teams. You don't want the marketing team to have to talk to the payments team to figure out how to send an email once payment succeeds. You want them to be able to discover that from some sort of event schema and to be able to understand the different attributes independently of that team. That's figuring out your events, your your target architecture, and the split up of that organization, the next part is also what I call the cloud team topology, but basically making sure you have teams doing different things. So streamlined teams, if you've looked at team topologies, that's really delivering value to the customer and building end-to-end. What you can also have is things like platform teams. When we come to serverless and event-driven architectures, platform teams need to change how they're operating. It's not like a traditional infrastructure team. They need to see themselves as a product to those other stream-aligned teams, building potentially CDK constructs that they package up and then can be used by other teams. This can be in a fully inner source mode, so any team can change those constructs, but you need to make sure there's ownership by that platform team to produce constructs that are useful to the team, as well as making sure observability is easy, as well as making sure the event bus is well maintained. So we've understood our vision and we've understood the topology, both the architecture and the team structure we want to get to. The next part is making sure that the team we have is going to have the skills to be able to build in the paradigm and the technology that we're moving towards. Your existing team, if you think back to that example of bringing in a whole load of new people and telling them to basically build the same system, the existing team understands the existing system. They understand the domain complexity. They understand the institutional knowledge. We need to bring them along on the journey. But embedding experts at the start can be a good way to speed up that learning. There's a big cold start time when you move from a monolithic development mode in a potentially legacy framework to do fully serverless event-driven architecture. There's a lot that needs to be learned. The learning curve is quite steep. But embedding experts can also feel like a threat. It can feel like, actually, are these guys just building the new stuff? Is my job safe? What's happening with the existing system? And here, it can be really useful to give people a path. Something that I use is called the serverless skills matrix. So we break down all the tools and technologies someone's going to need to work in a particular architecture and a particular paradigm. It might break out a Lambda function. How do I write a Lambda function? How do I run it? How do I test it? It might break out paradigm patterns, an event-driven architecture. How do I define an event? How do I do contract testing? Putting that all together, you can let individual team members rate themselves on a weekly basis, but with a coach to challenge them, and actually build up a little bit of a plan about how they're going to learn and progress. This can be aggregated across teams, and one of the most interesting things for me is spotting, well, if you have an expert here on DynamoDB, and you have someone who doesn't know DynamoDB well in this team, how can we in the next sprint make sure we do pair programming between those two people, share the knowledge, and build up the aggregate knowledge inside the organization? So we've understood the vision, we've understood the topology we're moving towards, and we've understood how to create sort of psychological safety in learning a new technology and a new paradigm. Step 4 is probably the most controversial part. This is minimum viable migration. So how do we avoid that big bang mindset of building everything and then releasing, and fingers crossed everything works? And for me, that's really avoiding what I call feature parity paralysis. So we have an existing system as is, which is going to have SSO, email, core feature X, legacy feature Y, and we have a system 2B where we're gradually building up that functionality. Right now, we don't have core feature X, so we can't really go live to production because users can't really use it if they can't, for an e-commerce, pay for something. Maybe there's opt-in ways of doing it with some sort of SaaS products, but largely you're quite blocked at this point. The key is, how can we have two systems in parallel so we can gradually release new functionality? And this is what I call minimum viable migrations. It's actually the talk I gave at EDA Day a couple of years ago, so you can find the talk there with more detail. But I'll run through some of the key parts briefly. So a minimum viable migration is a usable migrated version of an application from one domain or paradigm to another, maybe from monolithic on-premise to fully event-driven and serverless, with a subset of features to be used by some or all customers. If we think about two domains here, we've got the as-is domain and we've got the 2B domain. This might be, as I said, on-premise monolith. This might be fully serverless event-driven architecture. And we have 3 core areas of functionality, A, B, and C. How do we get to a position where we can have 2 systems live? The functionality of feature A is there, but the other functionalities are B and C, and we have a distributed experience across the 2 systems. We can rethink our Big Bang migration to look something like this. Gradually, we're removing functionality or stopping to use the functionality of the as-is system, and gradually we're building it up in the 2B system. But this requires communication between the 2 systems, which could create coupling and could create sort of distribution of architectural decisions we didn't quite like from our old system. So we need to have an event-driven communication between the as-is system and the 2B system. The requirement for an MVM approach, a strangler figure approach, but with a little bit more around it, is really to build an event-driven architecture. Have a defined list of events, have a schema, and have an event bus in the new system. We also then need the ability to emit events from the old system and the ability to react to events in the new system. Just a quick side note on eventification data liberation. Basically, a lot of times I've seen people try to modernize to event-driven architecture. They build system A, system B, system C. These guys have an event bridge. They communicate really nicely. And now and again, they have to do a synchronous request back to the legacy system. This creates coupling of many forms, and also it creates a lot of lack of availability of these systems if the legacy system is ever down. So we really want to avoid point-to-point dependencies whenever we can. One strategy for this is eventification, so having a data source mechanism in front of the legacy system, publishing then events and publishing them onto an event bus, which is consumed by system A, system B, system C, and those systems can then create projections of the data as they see fit. So if we have a legacy app with a legacy database, we can do change data capture to push things up to an event bus. We can also do it with application code triggers. We can make change to the legacy code, for instance, using the AWS SDK to push events directly into Event Bridge, and then we can respond to those in the new system. Finally, you can do it with log capture. You can do some complex regular expressions, or you can now leverage some forms of AI to start to aggregate things. That bit's still a bit in research and development. But whichever way you do it, the key is to put an anti-corruption layer between the two systems. So to make sure we don't repeat the domain modeling of this system in our new system, to convert synchronous request responses to events, and also to change how we're modeling the data inside of those events. I realize I've gone on a tangent about eventification, but one more tangent before we loop back into what we're talking about is when moving away from a legacy monolith, it's important to actually analyze what we're moving away from. We might be moving to a completely different paradigm, to a completely different technology, but we want to analyze our monolith to find patterns. Here, each of these circles is a different module of a code base, and each of these small dots in different colors is a different team from our team topology. We understand our streamline teams, and there is a platform team in there. And we can see that over here, one team is making changes to this module. No one's stepping on each other's toes. No one's getting in each other's way. Over here, we can see lots of different teams are working on the same area of code. It's very contentious. This can be a great indicator, maybe, to say this is our first minimum viable migration. We can split it out. It's not going to be too complicated. It's going to be quite low risk. This bit, we could say, should be quite a high priority as an MVM because so many people are certainly currently having contention in the same area. We need to pull this out and break it up into multiple different systems. But back to the staircase. We figured out our vision. We figured out the topology we want to have. We figured out how we're going to train people. And we found a way to avoid that big bang release strategy. The final part, and it's not the fun part so much in a tech talk, is the governance. How do we make sure that we have smooth operation through this transformation? And how do we make sure that we implicate both the product teams and the technology teams? And the best tool for that I found is creating what I call a digital delivery office, but having governance owned not just by technology alone, but also having the product team implicated in the success of a modernization. This means you can make joint resourcing decisions and also coordinate on the MVMs that go live and in what order. Going right back to the start of the staircase, it's all about vision here. That team, that DDO, needs to report on metrics around the North Star, input metrics that are derived that feed into that North Star, and as the modernization goes on towards the serverless event-driven architecture, to report on the medium to long-term business impacts. Stealing from Amazon rather than AWS in this case, has anyone read the book Working Backwards? So some of you are familiar with the concept of input metrics and WBR, Weekly Business Review. Weekly Business Review is a way that Amazon manages its organization. So they have a meeting where they look at a number of indicators, each of those indicators owned by somebody. Inspired by the same way of working, what I've done with some companies is a weekly modernization review. So based on those input metrics and based on the North Star, having a meeting each week with that digital delivery office to look at the metrics and see what's happening. Here we can see deployment frequency, and we can see it's owned by Pascal, and we can see, okay, deployments are going down, the frequency is going down. This is the modernization where it's supposed to be improving, but actually, historically, it's gone down in this week. That red line is last year's performance. Maybe there's something going on in the world, which is why we don't release. Maybe it's Christmas, maybe it's something else. But by having those indicators across the different KPIs and having this owned both by technology and business, you create buy-in on a modernization, and you create understanding of the work that's being done by technology. And this can be done on a weekly basis, and you can also do it on a monthly basis and share that more broadly across the organization, again, to increase buy-in. So putting this all together, for me, it's really about creating the right vision, making sure the whole organization is moving towards the same direction, having the right topology, the architectural topology, and then leveraging the reverse Conway maneuver to have the right team topology, training, creating psychological safety and a learning plan, and injecting experts at the start to make sure you short-circuit the cold start problem, and leveraging minimum viable migrations as a way to avoid the big bang. Finally, governance, not the most exciting part, but probably the most important parts of making this all work. So in conclusion, I'd say organizations are moving to serverless and event-driven architectures to realize the full benefit of cloud. And typically, I'm seeing that be reduced total cost of ownership and reduced time to value. The people challenges are just as important as the technical ones in getting this right, and we need to avoid that field of dreams trap. We can't build it and they will come. We also want to avoid any big bang. A big bang delays risk too far down, it doesn't build a culture of continuous delivery, and it will create a fight between tech and product. Leveraging the MVM framework and a strangle of fig approach can be a good way to do that. And there are common lessons you can learn across transformations towards EDA and serverless, and you can find those in the serverless staircase. And don't forget to look back at your legacy monolith, but take a step back. Don't look into the code necessarily, but look at the structure and the way teams are changing that code to understand the patterns inside of your teams. If you're interested in MVMs, I actually spoke here last year on the topic, so you can find a white paper on the aleio website, which you can have freely. But also, I'm going to be around today, and I think we do have some time for questions if anyone has any questions. Thank you.